Welcome once again. Still on sets and operations on sets. We are to continue today with the problem solving, but today we are going to look at three sets problems. And we are starting that with a WASI 2021 theory question number 6, which is in a military camp. 50 officers had a choice of beans, plantain, and rice. Of these officers, 21 chose beans, 24 chose plantain, and 18 rice. Also, 3 chose beans only, 9 plantain only, 2 rice only, and 5 chose all kinds of food. Thou should first of all illustrate the information on a Venn diagram. Use the Venn diagram to find the number of officers who chose plantain and beans only, exactly 2 kinds of food, none of the 3 foods. At the solution of this particular problem, just like in the 2 sets problems, we are first of all going to extract the information where we have you being officers, and then we have number of you to be 50. B represent those who chose beans, so number of B will be 21. P representing those who chose plantain, so number of P becomes 24. Those who chose rice represented by R, which means number of R should be 18. Those who chose beans only will be 3. Those who chose plantain only will be 9. Those who chose rice only will be 2. And those who chose all the 3 kinds of food, that is B intersection P intersection R, will be 5. Then those who chose none of the 3 foods will be represented by a variable. So let's say D. We can now represent this on a Venn diagram as seen below. So have here beans to be 21, plantain to be 24, rice to be 18. Then beans only 3 here. Then we have plantain only 9. We have rice only 2. Then 5 choose all the 3 kinds of food, so we have 5 here. We'll be left with this, that, and that. Since we don't know them, we represent them by variables. So let's say A, B, C here. Then those who did not choose any of the 3 is represented by D. So, and the universal is here. This gives us the Venn diagram. Now, when we consider the Venn diagram, taking the components within the red circle, the red circle here represents beans. Taking the components within the red circle, when we add all the components, we should get 21. So let's do that and see. So have A plus B plus 3 plus 5 should be equal to 21. We can group them so that we'll have A plus B equal 13. Because 3 plus 5 gives us 8. 21 minus 8 gives us 13. We can label that as equation 1. Also, when we look at the green circle, which represents plantain, when we add all the components, we should get 24. So we'll have A plus C plus 9 plus 5, and that should be equal to 24. Grouping items, A plus C should be 10, and that becomes our second equation. Because 9 plus 5 gives us 14. 24 minus 14 gives us 10. So this becomes our second equation. Then when we look at the third circle, the blue circle here, that represents rice. When we add all the components, we should have 18. So B plus C plus 2 plus 5 should be equal to 18. Grouping items, B plus C should be 11. That gives us our third equation. We have 2 plus 5 giving us 7. 18 minus 7 gives us 11. So that gives us our third equation. When you look at equation 1 and equation 2, see that they have common terms, which is A. So we have to solve these two equations, or solving them, we have to solve in order to find A, B, and C. We have to solve the three equations here simultaneously. So first of all, let's pick equation 1 and 2. When you look at that, you see that A here in equation 1 and A in equation 2 have the same coefficients. So because they have the same coefficients, if we want to eliminate A here, we can easily subtract them. So let's say that we are subtracting equation 1 and equation 2. So when we do that, A minus A here becomes 0. Then we'll now have B minus C. That will be equal to 13 minus 10. That will be 3. So we can label that to as our equation 4. When we also look at equation 3 and that of the equation 4, equation 3 here and 4 here, you see that they have the same components. So let's subtract the two equations so that we'll have B plus C equal 11, that is the equation 3, minus B minus C equal 3, that is the equation 4. So when we do that, B minus B, see that B will be cancelled or eliminated. Then we'll have C minus minus C. Then negative becomes positive, so that we'll now have C plus C, and C plus C gives us 2C, and that will be equal to 11 minus 3, that gives us 8. To find C, we divide through by 2, and that gives us C to be equal to 4. So for Roman number 2I, or for BI, we were asked to find those who chose plantain and beans only. Plantain and beans only, which is A. So doing that, we'll have A plus C equal to 10, which implies A plus 4, since we now know C is 4, equal to 10, making A the subject. A will be equal to 6. 10 minus 4 gives us 6, so A will be equal to 6. So we can therefore conclude that 6 officers choose plantain and beans only. Again, when we To find, we have found the value of A and C. To find the value of B, let's put C into equation 4. Putting C into equation 4 was B minus C equal 3. So since C is now 4, we'll put B there, the value of C there. That gives us B minus 4 equal to 3. So let's group like terms. Grouping like terms, we have to send the 4 the right hand side, so that we'll now have 3 plus 4, which will be equal to 7. So for Roman number 2, we were asked to find those who choose exactly 2 kinds of food. We now know the value of A, B, and C. Those who chose 2 kinds of food will be equal to A plus B plus C. So that gives us 6 for A, plus 7 for B, and plus 4 for C. So I have A was 4, so that will give us 17. So conclude by saying that 17 officers chose 2 kinds of food. Then for Roman number 3, those who chose none of the 3 kinds of food, we first of all have to find the value of this D. So finding D, we have to add all the components here, and we should get 50. So adding the components, we'll have A plus B plus C plus D plus 3 plus 9 plus 2 and plus 5 should be equal to 50. So when we simplify, we still have replacing the values of A, B, and C. We have 6 plus 7 plus 4 plus D plus 3 plus 9 plus 2 plus 5, and that should be equal to 50. Grouping, we have D plus 36 equal 50. That gives us D to be 50 minus 36, and D will be 14. So we can conclude by saying 14 officers chose none of the 3 kinds of food. For example 2, which is a WASI 2019 theory question 10A. In a class of 50 students, 24 like football, 21 like basketball, and 18 cricket. 6 like football and basketball only. 3 like basketball only. 5 like all the 3 games, and 14 did not like any of the 3 games. We should first illustrate this information on a Venn diagram. Find the number of students who like football and cricket only. Those who like exactly one of the games. Looking at the solution to this particular problem, first of all, by listing the information or extracting the information from the question, we have U to be students, so I have number of U to be 50, number of F, where F represents football, to be 24, B represents basketball, so number of B will be 21, C will do those who like cricket, so number of C will be 18, football intersection basketball only will be 6. Those who like only basketball will be 3. Those who like all the 3 games will be 5. Then those who like none of the 3 games will be 14. So representing that on a Venn diagram, we have I, that, and this represents the Venn diagram. So when you look at that, we have this given football and basketball only. We have basketball only given. Those who like all the 3 games given. We are not giving football only, basketball, football, and then cricket only. So we represent them by variables. So we have A, B, C, and then D, where none of the 3 will be 14. So have this. So considering the Venn diagram, we can have, looking at the green circle here, we can have C plus 5 plus 3 plus 6, and that will be equal to 21. This means we'll have C plus 14 equal 21, and C will be 21 minus 14, that gives us 7. So the value of C will be 7. From the red circle 2, which represents football, we can also have A plus B plus 6 plus 5 equal 24 here. So grouping like terms, we'll have A plus B equal 24 minus 11. That gives us A plus B to be 13. We can equally make B the subject here, so that B will be equal to 13 minus A, and we can label that as our equation 1. Then when we look at the Venn diagram, when we add all the components here, we should get 50. So we'll have A plus B plus C plus D, then plus 3 plus 6 plus 5 plus 14 here equal 50. So that we'll have A plus, we know that we'll now have, we know that B is 13 minus A. So we are going to substitute that. So we'll now have our A here plus the B, which will now be 13 minus A, plus C, which is 7, so plus 7, plus D, plus 3, plus 6, plus 5, plus 14, and plus 50. So that this A and that will cancel. So the remaining variable here will now be D. And when we add all the numbers, we'll have 48. So D plus 48 will be 50. That gives us D to be 50 minus 48, which is equal to 2. For the Roman number 2 alpha, we were asked to find those who like football and cricket only, and that will represent B here. So to find the value of B, we have to first of all add all the components in the third circle. So doing that, we have B plus C plus D plus 5, and that should be equal to 18. But we know the value of C and D, so replacing them, that gives us this, where B plus 14 will now be 18, making B the subject. B will be equal to 18 minus 4, which is equal to 18 minus 14, which is equal to 4. So we can conclude that for students like football and cricket only. Then to find those who like exactly one of the games, that is the Roman number 2 beta. Those who like exactly one of the games will be this, that, and that. So add a to 3, then to the value of d. But we know the value of d already is a, we don't know. So find the value of a. We know that a plus b is equal to 13. That means a plus 4, which is the value of b, will be equal to 13. And that gives us a to be 13 minus 4, which is equal to 9. We can now substitute the value of a into a plus 3 plus d equal, so this will now give us 9 plus 3 plus our d, which was 2, and that will give us 14. So therefore 14 students like exactly one of the 3 games. Thank you very much once again for watching, and please subscribe, comment, and like, and also share. But keep on for the next video. Thank you, and bye for now.